Greetings and welcome to my new calculus channel. My name is John Gabriel, and today it's going to be the mean value theorem again. Some idiot wrote a very long rant on my YouTube channel, which I deleted and I didn't even respond to. But he was trying to tell me that I don't understand the mean value theorem. Well, the problem here is that as many times as I've pointed this out, the buffoons or the chumps of mainstream academics, math academic world, they don't understand this. They just simply don't get it. Now, look, according to the Britannica, the theorem states that the slope of a line connecting any 2 points on a smooth curve, okay? Not a continuous curve like that BS that you find on Wikipedia for the articles on mean value theorem and fundamental theorem of calculus. It has to be smooth. It is a property of smooth curves, you morons. Okay, it's the same as some slope, as the slope of some tangent line to the curve at a point between the 2 points. In other words, at some point, the slope of the curve must equal its average slope. No, it must equal the arithmetic mean of the y-ordinates of the derivative. Okay, that's the correct statement. And I'll give you the correct statement because I've written an article on it. This is the correct statement. It says, given any smooth function f prime of x, okay, meaning it's a derived function, the arithmetic mean, or more accurate name is level term, of all the y-ordinates of f prime over the interval ab is given by that difference, okay, where c lies in between. That such a c exists is an unremarkable property of smooth functions. That is, there is at least one y-ordinate which represents the level y-ordinate of all the y-ordinates in the interval a, b. Okay, that's the mean value theorem. Nothing else. Don't write bullshit on my channel that, it says given any c or given any interval. It doesn't say any of that. Okay, it's talking about the property of smooth functions over an interval. Okay, in other words, what does smooth over an interval mean? Let's see quickly, because even mainstream academia has no idea what smooth means. So let's see. Okay, so to be smooth over an interval, so if you have a function, let's just do this. It's like this. Okay, now it mustn't be discontinuous, okay, because that would fail. All right, and also let's just make this a bit bigger. Right, to be smooth, there must be no jumps. Okay, so that would be smooth, right? And there must only be one tangent line possible at every point in the interval. So if you're looking at this interval, it doesn't matter if it's not smooth here. For example, over here, it could go something like this, okay? In which case, calculus can be applied because this has more than one rule. In other words, this is a composition of many functions. But over here, it means that you can only have one tangent line with the exception of inflection points, okay? So, for example, if you have the cubic like that, there is no tangent line there, contrary to what the morons in mainstream tell you. And how do I know? Because my ancestors, such as Apollonius, the great geometer, proved that a tangent line may not cross at the point of tangency. Okay, he proved it. If it does cross, it's not a tangent line. And you'll say, well, what happens if we calculate these areas here? Well, if you calculate these areas here, you're going to get 0. Why? Because these are negative and these are positive, right? And so it's symmetrical about the y-axis, so you're going to get 0. Does the mean value theorem fail in that case? Actually, no. It in fact produces 0. Because why? Because the mean value theorem doesn't care about inflection points. You absolute imbeciles. How many times do I need to tell you that? The mean value theorem does not care about inflection points. Okay, so you can calculate, if you have an inflection point, let's say over here, you can calculate the area there. And if there's an inflection point right there, the mean value theorem doesn't care about it, right? So let's just get out of there. So I'll give you a link to this article. It explains everything you need to know about the mean value theorem. Right. If you happen to watch this video, do not comment and tell me that I do not understand, you imbecile. I'm smarter than you. I'm smarter than anybody else on the planet. I am the greatest mathematician today. Okay. Don't you dare get on my channel and say you know better than me. You don't, you fucking moron. I'm John Gabriel, and this is a new calculus channel. Till next time,